Welcome to the CAD 2 Week 8 tutorial. Now this is going to be part 1. This tutorial is specifically going to be on making the assembly itself. After you've reviewed the lecture, we have a couple of links here. One for the assembly blueprint, one for the assembly parts, and then the tutorials here are paper tutorials on the drawing. But I figured it would be helpful to have a tutorial for a refresher on making the assembly itself. So, once you've downloaded the parts, we can take a look at the blueprint. From here we can see we've got two plates with a bushing in between them. Then we've got a pin through the middle, some bolts through the 4 corner holes, along with washers and hex nuts on each side. And if we look at our bill of materials, that lines up. 2 of part 1, the base plate, 1 of part 2, the bushing, some preferred wide flat washers that are 3/8, a hex bolt that's 3/8-16 by 1.5 long, a hex nut that's 3/8-16, and a dowel pin that's 7/8 by 1.5. That's what all these abbreviations mean. Everything here that's listed as standard is going to come from the toolbox, while the first 2 are going to be the actual parts that we download. So you want to download those parts, and they're going to download as a zip file. You'll want to extract them into their own folder. From there, you can either open them or just go straight to opening SOLIDWORKS. In SOLIDWORKS, we're going to hit New. We're going to browse to English because this part is in inches, and we're going to make an assembly, which is the second icon here. All right. Now that we've got an assembly file open, again, you may want to go into not simplified view if you are. If you don't get this pop-up, we want to insert components. That's what this pop-up is, and we're going to browse for them. We are going to find part 1, and we're going to import part 1 first. So we're going to hit Open. Now, this is something that's on the CSWA. Right now, I can click to place my part in 3D space, but that will just place it arbitrarily in 3D space. I don't want to do that. What I want to do is align the origin of this part with the origin of the assembly. And to do that, what I do is simply select this green check mark. That will align my part's origin with my assembly's origin. You can see that they're overlapping. My right plane lines up with my right plane, top with top, and so on. That's very important for the CSWA specifically. Most of the time that doesn't really matter. It only affects where your measured center of mass is, but that's how they check it on the CSWA. Now for the second component, we're going to go back to Insert, Browse, pick another one of this plate, and I'm just going to place it in space. Insert a third component, and grab one of the bushing. Now, if we look back at the assembly drawing, the bushing should sit flush, and the 2 plates are stacked on top of each other. So to actually connect things in an assembly, we use the Mate tool. The Mate tool basically connects whatever 2 things you select. So in this case, if I select 2 flat surfaces, it's going to make those 2 surfaces coincident by default. But I could make them parallel or perpendicular. I could just lock them together. I could set a distance between them, set an angle between them. There's a lot of options, but it's going to default to coincident. Now, because this is a hole pattern lining up, I usually like to try and make my mates between things that are actually going to line up. In this case, the center hole here and the center hole there are going to line up. When you pick 2 circles, it automatically makes them concentric, which lines up the axes of those 2 circles. And it gives you the option to lock the rotation. We only use lock rotation on things that have no feature that could physically orient it. This plate does have orienting features, so we're going to leave it unlocked. Now, my bottom plate can rotate, but is otherwise lined up. And to do the last alignment, I can either pick 2 faces on the side, or I could pick 2 other holes to line up those holes. Doesn't really matter so long as we end up with that plate aligned, and I can see now there's no minus symbol next to that plate. Next I'll do the bushing. So the bushing will again be circle to circle. This one is purely round, no orienting features, so I will lock rotation. And then top of the bushing to top of the plate. Perfect. So that's my 3 inserted parts aligned correctly. Now I need to grab these toolbox parts. I need a flat washer. I need a hex bolt, a hex nut, and a dowel pin. Now the hex bolt, hex nut, and flat washer are all going to go together on this corner. So we're going to use a command called copy with mates to duplicate that bolt, nut, washer pattern to each corner. So those parts are going to be pulled from the toolbox, and our toolbox is stored on the right side in the design library. So we'll open the design library, go to toolbox, and click add in now. From here we're going to go to ANSI inch, and I'll start with the bolt first. So we'll go to bolts and screws. This is going to be a hex head screw. There's hex head. And there's a standard hex bolt, so I'm just going to drag that in. Once it's dragged in from the right side, I get the configure component option to change its properties. So this is a 3/8-16 bolt, and for length it is 1.5 inches. I can hit OK. And it does give me the option to place more, but I'm just going to leave the 1 in space for now. My next component, which I can get to by hitting the back browse button to go back to here. So again, I'm just in ANSI inch on the main selection page. I'm going to grab my washer. So I'll go to washers, circular washers. That is not the kind that was used, so we'll go back. Plain washers, there we go. And we used a preferred wide flat washer. So here is the preferred wide flat washer. Size is going to be 3/8 to match our bolt. I can hit OK. And I do need 2 of these, so I will click and place a second. Finally, we go back to the design library, go back 2 times to get to nuts. We're going to grab a hex nut and grab a regular hex nut, and that will be 3/8-16 as well. Okay. That is my set of standard components for the corner. This set of components is going to be on all 4 of these corner holes. But what I'm going to do is assemble it together and then copy it to the other locations. Now when using this command in this trick, we want to make as many of the mates between the fasteners as possible. So what I mean by that is I'm going to mate the washer to the bolt. I will lock rotation. Then I'll mate the washer to the top of the bolt. I could have mated this washer to the plate and then mated the bolt to the washer, but I want to mate the fasteners to each other as much as possible. It makes the copy with mate command work much easier. Now, the bolt does need to align with this hole. That I do have to do. And I'm actually going to not lock rotation because I like to align it using the hex head. I think it looks nicer. So the bolt lines up with the hole, and then the top of the washer goes to the top face. It's got me in a parallel mate. I need coincident. There we go. Now the next washer, inside of the washer, goes to the bolt. Lock rotation. And top of the washer goes to the bottom face. I can hit OK. Inside of the hex nut goes to the bolt. I will not lock rotation. Top of the hex nut goes to the washer. Hit OK. Now, you can lock rotation on the bolts. It's not that big of a deal. But when you have multiple copies of a fastener, it just looks nicer if they're all aligned. So what I like to do is take one face of my hex head and make it parallel to an edge of the part, just so that way all my fasteners are facing the same direction. It looks a little nicer. Okay, my bolts, both my washers, and my hex nut are fully defined. Now I need to duplicate them to the other corners. So I'm going to hold Control and select all of these items from my feature tree. Once I have them all selected, I'm going to right-click and select Copy with Mates. There are my selected components. Confirm that they're all there. If not, you can select or deselect from the graphics window and hit the Next option. It's going to list all the mates that are used between any of those components and anything not selected. This is why we tried to keep the mates to each other. I can preview what mates they are by clicking into the box. So the first one, or the one at the bottom, is the parallel between the nut and the side plate. I want that alignment to stay the same, so that's going to repeat. The next one up is the parallel between the bolt and the side. I want that to repeat. I have the coincident between the washer and the bottom. That's the same face, so that's going to repeat. And the coincident between the washer and the top. That will also repeat. The only thing that's going to change is my initial concentric that tells the whole pattern of bolt, washer, and hex nut where to go. So with the rest of these set to repeat, all I should have to do is click the next hole where I want the fastener pattern to go. That drops everything into place, and I can hit the green check mark to confirm that one's location. Then I click the next hole that I want this pattern to go to, and again hit the green check mark to confirm that location. Select the third location, hit the green check mark to confirm, and then finish by hitting the cancel command to not input that extra set. Now on the left side I can see all my components are inserted and all are fully defined. And that was much faster than inserting 4 bolts, 8 washers, 4 hex nuts, and doing all of those mates manually. We just repeated them all. We only had to do it once. The last thing that's going to go in here is that dowel pin. So we'll go back to the design library, go back here, go to pins, straight pins, dowel pin. Drag that in. It is a 7/8, and my length is on the left side. It is a 7/8 by 1.5. I can hit OK. And based on the image I see in our assembly, the rounded top is up, the tapered edge is on the bottom. So we're going to use that for our alignment. So we'll go mate, circle to circle, lock rotation, and it lines up the bottom face with the bottom face, so we'll do those two. Hit OK, OK, and that is our assembly. Go to my isometric view, and that should be good. Important things to remember: your title and author come from the file properties of whatever file is making the drawing. In this case, this is the assembly file, so you'll want to put your title and your initials in the file properties of this file. This will be the locator assembly. Additionally, you want to make sure you save this into the same folder as your models. SOLIDWORKS doesn't like assemblies that are broken out into multiple folders. They prefer them to be in the same folder as the model. There's the naming convention. I can save that. And there we go. That completes your assembly. You're ready to make the drawing.